Okay guys, now this is probably the third time I've tried recording this video today. I've had a little bit of issues with the picture, but what we're going to do here is I'm going to show you how, after we've read in a map, a shapefile from Geopandas, how we're going to map out the data into a choropleth map. And first, let me just show you the general idea that we're going for here. This is the Geopandas documentation page, geopandas.org. This is where you can look up, just about everything within the Geopandas library. This is the mapping tools, and what we're going to use is our Bucks County map. Make a choropleth map using some of these commands that you'll see right up here. To make a map similar to this. Pretty much going to just follow those instructions, but first we have to work through the data and just do a little bit of cleaning as well. Now, I've done this a few times already, so I'm sorry, this notebook's already going to be pretty much filled out. I'm just going to try and walk you through what I was doing in the previous videos, but here we go. First things first, going to go to our first Python notebook directory. And our tax calculator is where I have everything, since that's the data we're going to work off of. Scripts, activate, back one, and Jupyter Notebook, and enter. There we go. Okay. Now, the problem that was in the last video was that apparently it wasn't loading exactly the entire web page, so you didn't see what I was typing at times. So I'm going to just go ahead and bring up this one, this notebook mapping with Geopandas. Now this code here is the same thing we did in the end of the last video for importing the first Geopandas data frame, the shapefile. These are the libraries that I like to use: pandas, numpy, geopandas, matplotlib, matplotlib.pyplot, SPLT, and a magic command, which is %sign matplotlib inline, so that we can have these maps appear like they are here. So just assign the variable to the map, and what I'm doing here is I'm taking the PA towns variable that I've set the map at, and I'm searching within that. The county name column is equal, double equal operator for whenever you want to match string or match a value, and the word Bucks, and everything is uppercase in this data frame, and I'm assigning that to the Bucks towns variable. And as you can see, it plots it out pretty nicely there. Now this is actually all the code from, I think it was this notebook here. No. Okay, it was this notebook here. Basically, this is from whenever we made a tax calculator, and I just took all the lines of code that we ended up using to make these charts here, and oh yeah, that's right. I put everything just in one single cell here. So this is all of that notebook information, and we're just going to go ahead and make our tax calculator data frame right here. Now, there's a thing, what we're going to do first off is we have to merge this data together. And as you can see in our Buckstown map, we've got a lot of columns here that aren't really going to matter. And all we really actually need are the town names here. I ended up keeping another one that we can't see right now. It's the Phipps square mile, just because I know I'm going to eventually want to get in population numbers and see how many people are per square mile. And also class of M. Something about Geopandas, whenever it loads in a data frame like this, it only allows so many characters of a name to go in, so it tends to cut them off. So this is actually class of municipality, class of M. And here I had just printed out all the column names, so we had it, and I copied and pasted that into here, and I just brought down what we need. And I'm going to change this to Bucks 1 because I kept on making a mistake. So Bucks 1, and there we have it. So the first thing I wanted to show you was that whenever we go to merge data, this is a few problems to look out for. For one, I tried doing a full outer merge to see if I could bring the two columns together, and you'll notice that this is a PD merge, which means that is a pandas command here, a pandas function. Works just fine for Geopandas, but if you want to maintain a geo database, you need to put your geo data frame, which in this case was Bucks 1, first, and it will maintain the geo data frame. If you put the df3 here first and then Bucks 1, it will try and do it as a regular data frame, and because there's this really long geometry column that it doesn't know what to do with, it will fail to load. But that's the general rule. Now in this one, we're trying to full outer merge, and that didn't work. You can also do left, which means it's going to be keeping the values on the left, and well, particularly keeping the values on the left there. Still doesn't work. The reason why is because we have all these names in uppercase, and there's no township at the end. And the problem here is that what we need to do to fix this is we need to take the class of M values, convert them all to a single format. This was, we did that, check that by bringing up Bucks 1 class value counts, and we saw 2 township, 1 township. That's first class and second class townships. So we needed to change the string, and I made a new column here. And what I did was I took Bucks 1, and so we'll go over here to what's actually happening in order. So it's going to bring up our variable Bucks 1, the class of M column, and then through the string of that column, it's going to look for 2 township. I put a pipette here, and that's the backslash button. Only hold shift to make the pipette, and just to basically tell it, okay, if it's 2 township or 1 township, just make it TWP. And there we go. So then the next thing that we had to do was merge these two together, and I put them into a new column called towns. And all you do is just print out Bucks 1, excuse me, let me go back here, Bucks 1 dot township borough plus space plus, and space and quotation marks, sorry, plus Bucks 1 class of M1, our new column. Right, I did forget about that. So on the PD merge, one of the reasons why this didn't work was because of, for one, they didn't share the same column name for 2 things. The data frame 3 has township underscore borough for its municipality names, and this one was municipal 1. So to change that, I did a Bucks 1 dot rename columns equal open curly bracket municipal underscore 1 colon, and then quotation marks township borough. That's the existing name, and the colon separates it, and then your new name goes here, close curly bracket, comma, in place equals true. And the in place equals true allows you to retain the same variable without having to make a new one. Retain the changes in the existing variable. So then I tried the township Bucks 1 again, and this time, although they had a common column to merge on, nothing matched. And the reason why is because the 2 townships don't match here. Upper make field is all in caps, and it doesn't end with TWP. Oops. So what we need to do is bring this over to here, merge these 2 columns essentially. So to do that, we looked up our two values, 2 township, 30, 1 township, 1. And I wrote this line here to say basically bucks1 dot class of m dot string replace. So that's the function I'm calling. And whenever you separate two values with a pipette within the quotation marks, it basically says look for these two values here and then replace it, separate with a comma, this value. And that gave us our columns where we ended up with. So now we can merge bucks1 dot township underscore borough plus open quotation marks space close quotation marks plus bucks1 dot class of m1. Now we then assigned a new variable because we only really wanted the towns, the Phipps square miles, and the geometry. And so now we can, bucks2. Now you can see they're a little bit closer, but they're still not going to match. For one thing, I had to change the name of the township borough to towns so that now these two will match on a column name. But whenever we merge them, we still don't get it right. And the reason is because everything is still in completely uppercase here. So, let's see here. How did we fix that? Right. Okay, so they weren't matching because these names here are still all in uppercase. And so to fix that, what we're going to do is we're going to bring up bucks2 dot towns dot str dot I'm sorry. We're going to call a function called title. And what that's going to do is it's going to make it like a title. First letter of every word is uppercase, just like we have just like we have in the data frame up here. So we can't do an in place on that one. So we're going to save the column value again now as towns with the string for the title. And there was one other issue with the replace function here. Whenever I did it one more time, basically it almost completely matched. We were missing about 4 towns. And the reason was there's a town called East Rock Hill, and in our tax calculator, the East was just a simple abbreviation, E space and then a capital R beginning Rock Hill. So I'm doing a call function to replace the E space R with East space R. And then there was another town, 2 towns actually, upper and lower Southampton. In the Bucks County tax millage guide, they were just abbreviated to upper South and lower South. So we're replacing the word South with Southampton. And then there was one other one that was really weird. It was a Haycock Township. It ended with a period for some reason, so we just got rid of the period, replaced it with nothing. There's no space in between these quotation marks. And then just for good measure, I did string.strip, which strips the white space away from the ends, each end of all the values in the data frame, in the column, in the column, so that we don't run into any other issues. And from there, I perform the same, another merge on towns. And just to confirm that it works, yes, there are 53 lines here, but pandas and Geopandas start with 0. So we have all 54 towns. Everyone has a polygon, and we have the millage here. So, what can we do with it? Well, I'm actually going to enter one above here, And let me show you the very first one. If you just in the very basic way to plot, if you do that, you get nothing really all that interesting. So what you want to do first is assign a column. And basically what you're looking for here is what kind of measure do you want to assign. And I want to map out, let's say the total millage. I would like to map that out. So column equals quotation marks total millage, and it's a little bit weird because it doesn't really, I guess, understand what I'm asking for here. So we are going to bring in the first part of our choropleth, which is CMap. This is assigning the colors OR-RD, orange, red. Still not quite right. So why? Well, we're going to give it a scheme, a color scheme. In this case, it's going to be quantiles. Quantiles are just basically kind of what you can already see in the map below. There we go. So there we can see the total millage bills are all over the place there. And that map is a little bit hard to read. First, let's bring in a legend. Legend equals true. And now that map is still even harder to read, and we have nan values in there. So to get rid of the nan values, we're going to do the same type of filtering method that we saw above to get just to Bucks County. But in this case, we're going to go test map dot, let's say, total millage. Ooh, what happened there? Oh, okay. Going to do test map 1 dot total millage dot not null in parentheses. There we go. So now we have this here, but that map is still pretty hard to read. So we need to change the size of the map. Fig size equals, in parentheses, we're going to do 10, no. We're going to do 15, 15. And there we go. The map's a little bit easier to read now. I'm not really wild that there's a huge gap between 15 to 156. Certainly seems like there's a lot of weird room there, and that's fine for now. This is the standard way to just sort of take a first glance at the data as you have it. So what I did just underneath was basically the same thing, only in this case I took the average total bill is not null, and I plotted it on the average total bill, CMap OR-RD, scheme quantiles, and yeah, still 15. And then I did the same thing over here. I left that filtering the same because it's not really going to affect us. We just want to get rid of the null value, and what was really killing it was that Telford down here is split between two counties, and it just got, and that's what threw off the map. But here we did the average residential home value, and in this one I just went with school mills. So that is basically how you can map out data within the Jupyter Notebook. There are more sophisticated tools to use with it, and you can check out more of the mapping tools at geopandas.org. They have maps with layers. We have, let's see, some other resources here, links to some Jupyter Notebooks, me making heat maps, which I gotta say, I'm probably gonna take a look at that. So there's a lot of things to do here. But one of the final things I want to show is that once you have this stuff done, of course, if you're in the newsroom, the Jupyter Notebook is not all that great to have for various reasons. One of the main reasons is it's hard to transfer this over. You can send this out as a JPEG or a PNG, I believe, but what I like to do is save it all as a shapefile itself. Now to do that, very simple. All you do is testmap1.toFile. This is Geopandas file writing name, file writing function, and then testmap1.rar, and that is just a driver to make an Esri shapefile. Enter, and it is done. And I guess we will see. See if I can load up. Okay, well, good news is I finally managed to figure out how to record the Tableau desktop here. So let me bring up our spatial file here. Now you can download Tableau. Just do a search for Tableau Public. It's a free download. TaxMap1RAR is what we did. And remember, with shape files, of course, there's always multiple files in this directory, but the only one that's going to open in Tableau is the .shp. But in case I forgot to say it in the last video or a video before, shape files must always be contained in the same directory. All four to up to 7 or even 8 files that make up the shapefile all have to be in the same folder. Otherwise, it's not going to load correctly. Let's go ahead and open this. Here's all the data that we made in Geopandas. And let me just take a quick look here. Number. I think that we're good. This is the average muni bill, average property value, average school bill. This is the problem with writing with Geopandas, is it cuts off those column names, so we are going to have to rename those if you're going to publish something on this. But I think that we should be good. Let's see what we can do real quick. And this is sort of basically recreating our choropleth map. Throw that in the details. There we go. Let's go with average total bill. There we are. And 1 second here, because I'm going to pull up our... Yeah, sorry, this looks so weird behind it, but this is what I like to do. I like to play with the colors a little bit. I prefer the temperature diverging, just to see what things look like to begin with. I like to use the full color range, and here it automatically sets the start, the end, and the mid section here. And this is where we can see the average the average total tax bill in each township in Bucks County. We can see that the Upper Makefield Township is very high, and just to add some context, is the average residential thing, so we'll throw that in the details. So we can see where it's highest, that's average residential is 72,580. Telford's, oh right, Telford's only in there because we have an average residential cost, but the tax is off, so that's something to keep in mind. But let's say that, well, what if, this average total is way higher than everything else, so it kind of throws off the entire skew of it. And that's where working with both of these together really comes into play here. I can go back to my little map here and test map 1 dot average total bill, and let's see what the median was. Ooh. So it's 5,512, and the mean, about the same. So I'm going to do the median. So 5,512, which I think was actually basically right in the middle for our colors. Kind of close. Let's go ahead and just change that 5,512. Okay. And there we are. Now I also think we could probably, since legends, I think they tend to read a little bit better if they're just round numbers. Say 348. Let's do 350. I don't think that'll screw this up. And let's do 11,300. Yeah, 5500. Okay. Now it does make it a little bit easier to read up here, I think. Yeah, we have a pretty good representation. It's kind of even throughout. We have a few very lower areas up here. Bedminster is an interesting place, especially since it's right next to some of the more expensive communities. The most expensive community here directly abuts. And then, of course, we have some much cheaper areas. And also, Quakertown is a lot more expensive than, well, it's more expensive than, say, some neighboring areas here. I don't want to say a lot more expensive. Or is it? Huh. You know what? Well, again, this is kind of why we map these out, so we can take a look at things, because this will give a reporter a good place to start with some questions. Anyway, that's been everything for this day. It's taken me like 10 hours to get done because of some technical issues, and I just thank you all very much for taking time to watch it. If you have any questions or comments, down below in the comment sections where those go, and I'll have a link to the Jupyter Notebook inside of my GitHub for this channel there, so you can find everything that you need by going to that link. And yeah, I think that's everything. Thanks a lot. Bye.